Hello Bobcats. In this video we will be discussing writing and balancing chemical equations. So let's first take a look at a chemical equation. Let's say I have hydrogen gas reacts with oxygen gas to produce water vapor. And then we'd have to balance it because you want to make sure you have the same number of atoms on each side. We have two hydrogens, two oxygens here, so I've got one, so I need to put a 2 here and a 2 here. Now, let's talk about what each part of this reaction equation is. And if we look at it, on this side, under here, these are reactants. And the arrow points towards the products. Now in this case there's only one product, but there could be more than one. So we have products on the right side, or the arrow points towards the products. Now this number here, up here, that we see, and I'm going to do it in red, so this number in red is called a coefficient. And the coefficient tells us how many molecules or moles of the substance are reacting. So I could say 2 molecules of hydrogen, and so let's write that down. What would that look like? 2 molecules of hydrogen. So that's there's one molecule, there's another molecule, so 2 molecules of hydrogen will react with 1 molecule of oxygen gas to produce 2 molecules of water. But we know that single molecules aren't what we look at. We have to have billions and billions and trillions of molecules. So rather than just saying 2 molecules, we would say 2 moles of hydrogen gas reacts with 1 mole of oxygen gas to produce 2 moles of water vapor. And so the coefficients tell us the number of moles or molecules, if you want to think of it that way. And they help balance the reaction. So if you'll notice, in this case I've got 1, 2, 3, 4 hydrogens. On this side I have 1, 2, 3, 4 hydrogens. On the reactant side I have 1, 2 oxygens. On the product side I have 1, 2 oxygens. Or I can look at it as 2 times 2 is 4 hydrogens. 1 times 2 is 2 oxygens. 2 times 2 is 4 hydrogens, and then 2 times 1 is 2 oxygens. And so that's how it looks. Then this part down here, whatever is in parentheses is the state of matter. So in this case the state of matter is gas. We have solid, liquid, gas, and another one called aqueous, and we'll go over those in just a minute. So what's important to understand is that we use the coefficients to balance, and that balancing is mass of reactants must equal mass of products. That's the law of conservation of mass. And we balance that, or make sure that the mass of each side is equal, based on the number of atoms being equal on both sides of the arrow, or based on equal numbers of atoms of each element on both sides of reaction. So we balance the number of atoms. And when we do that, we also get a balance in the mass. So that is basically what a chemical equation looks like. What you are going to be expected to be able to do is write chemical equations from word problems. So let's talk about writing chemical equations from word problems. Okay. So let's take an example and see what we need to do. If I have this word problem, when solid copper reacts with a solution of silver nitrate, the products are a solution of copper 2 nitrate and solid silver. So you would have to be able to write the correct formulas into a chemical equation and balance it. So if you don't write the correct formulas, you're not going to be able to balance it. So you got to be careful as you write this down. So let's go through this. And we know that we have solid copper. So copper is Cu, and it's a solid. Reacts with a solution. So we're going to reacts with or plus a solution of silver nitrate. Now remember, silver is an Ag, nitrate is an NO3, and I'm just going to write it. We know that silver is a 1 plus, nitrate's a 1 minus, so that means it's a 1-to-1 ratio, so 1 to 1, that's correctly written. And when it says in solution, we use the symbol AQ. AQ meaning aqueous or dissolved in water. It's a solution. It says the product or produces a solution of copper 2 nitrate. Now, so this is copper, which is a 2 plus, nitrate, which is a 1 minus, so we need 2 nitrates to go with 1 copper. And it's aqueous because it says a solution of that plus solid silver. Ag solid. Now, once we get it written down and you've written the correct formulas, you cannot change the subscripts. The subscripts must stay as they are. And so if we balance this, we'll notice that the copper is the same on both sides, the silver is, so we're looking at the nitrate. Now remember, nitrate in this case is a single unit. And I have 2 here and 1 here, so I have to put a 2. As soon as I do that, I now have 2 silvers. I only have 1 here, so I have to put a 2 here. And then I have 1 copper, 1 copper. So now it's balanced. Now, in this case, I gave you the states of matter, solid and solution. Sometimes you won't be given the state of matter. So let's look at what that would look like. So in another problem, this is one of them. This is another practice problem. We would have sodium carbonate decomposes to produce sodium, I'll start here, sodium oxide and carbon dioxide. Okay, so you'll notice here that I didn't tell you what the states of matter are, and you still have to write the correct formulas. And so we have sodium carbonate. Now that is, we know that carbonate is a 2 minus and sodium's a 1 plus, so that means I need 2 sodiums to go with the 1 carbonate. So that'll be Na2CO3, decomposes to produce, so now it's reacting to produce sodium oxide. Now oxide is a 2 minus and sodium's a 1 plus, so I need 2 sodiums and 1 oxide. So that would be Na2O plus carbon dioxide, or CO2. Now in this case, we go ahead and balance it. We have 2 sodiums, 1 carbon, and then 3 oxygens here, and then 1 plus 2 is 3 oxygen on this side. So it's already balanced. What we're missing are the states of matter. And I'll tell you right now that ionic compounds, all ionic compounds are solid at room temperature unless it says that they are in solution. So this is solid. There's nothing about a solution there or water, so it's solid. This is an ionic compound. There is no water involved and it doesn't say it's in solution, so this is a solid. And then this is a covalent compound. And right now what you will say that all binary covalent compounds that are small, in other words less than 60 grams per mole, this is 44 grams per mole molar mass, are gases at room temperature, except for 2 of them. The 2 that are not a gas at room temperature are water and ammonia. So water and ammonia are liquids, but all other binary covalent compounds will be gases. So ionic compounds are solid unless it says they're in solution, which we'd say aqueous, and then covalent compounds, binary covalent compounds, small binary covalent compounds are gases, except for water and ammonia. Now let's go on and look at symbols that we have in this. In fact, this would require a symbol right here, and we need to know what does that mean. So let's go over symbols that are involved in writing chemical equations. So symbols for chemical equations. So what we'll do here is we'll write the symbol here and the meaning over here. Symbol, meaning. So the first one is a plus sign. So this just means reacts with or is produced with. Okay. The next symbol we'll say is the arrow, and that means produces, makes, yields, words like that. And then it must be in the direction of the reaction. And RXN is short for reaction, instead of writing reaction out all the way. Now, one thing that we will not see too much of in this class, but you'll see a lot of it in Gen Chem 2, is arrows going in both directions, and this means equilibrium. And I'm not going to spend time discussing that right now because you will get plenty of it in Gen Chem 2. Then we have solid, liquid, gas, AQ, which means aqueous or dissolved in water, aqua stands for water, so dissolved in water, So that's a solution. Then we have, if you have an arrow with a delta sign over it, that's this triangle, that means reactants are being heated. I can also put with an arrow with, let's say I want a specific pressure, so let's say 2 atmospheres of pressure. So I'm going to tell, and that means the reaction has to be done under that pressure. So reaction under specific pressure. Let's say I want it at a very specific temperature, not just heating it, but I need it at a specific temperature, like a -10 degrees Celsius. So this is reaction at specific temperature. And then last one we'll address is a catalyst. So if you have something written over, like PT, or maybe MnO2, these are catalysts. And so a catalyst is a substance that makes a reaction occur faster. But it is not actually part of the reaction. Its bonds don't break and reform. It stays the way it is. It just makes it occur faster. So you can have, also we could say that the catalyst does not get used up. And that's why you put it over the arrow, because if you put it as part of a plus sign, then it says it's reacting with, but this doesn't react with. It just makes it go faster, and they don't get used up. So you should be able to recover all of your catalyst after the reaction is over. Oops. Okay, so those are symbols in a reaction equation. Next I would like to go over is how do we balance chemical reactions. So let's look at balancing chemical reactions. Or if you want to say chemical equations, but chemical reactions, chemical equations, balancing those, that's what we'll say. First, then most important, is write the correct formula of the compounds. If you do not write the correct formula, you cannot balance it. And once you have the correct formula written, you cannot mess with that formula. You cannot mess with the subscripts. You've got to leave it alone. We use coefficients to do the balancing. So do not mess with subscripts once you've written the correct formula. The next thing is you need to balance both sides based on reaction having the same number. So balance based on both sides of reaction having same number of atoms of each element. And when you do this, you will actually be following the law of conservation of mass. Because each atom doesn't change its mass, and if you've got equal number of atoms, you're going to have equal mass on each side of the reaction. So law of conservation of mass. Now 3 is guidelines. So this is, after several years of doing this, this is what I find to be the best way and easiest way to balance chemical reactions. So this is guidelines. The first 2 you have to do, you must do those correctly. But these are guidelines, and they don't always stick, but they work majority of the time in order, for order of balancing. So when I'm balancing a reaction, I follow this order. First, or A, start with metals, and followed by nonmetals. Oops, nonmetals. Sorry about that spelling. So followed by nonmetals. Unless the metals are alone. And I will explain that in just a minute when we practice one of these. We're just going to go through the rules first, then we'll practice. So B, guideline B, if there are polyatomic ions on both sides of the reaction, keep the ions together. Keep them together, and I'll show you what I mean about this in just a minute also. So just keep these in mind, and we will review them as we do a practice in just a minute, okay? So the next one, C, once a coefficient has been placed, make changes to both sides. Oops. Make changes to the other side of the reaction to balance what was changed by the coefficient. Okay, and remember, I'll go over these in just a minute. And D, this one's a little specific in that if it's doing a hydrocarbon combustion reaction, if doing a hydrocarbon combustion reaction, now combustion reactions are anything that reacts with oxygen, and a hydrocarbon is an organic compound, hydrogen and carbon. If you have a hydrocarbon combustion, the order should be, the order of balancing should be carbon first, then hydrogen, and then oxygen. Okay. And the last thing you should do, number 4, is once you're done, just count the atoms to be sure the equation is balanced. So count atoms to be sure that the equation is balanced. Okay, so let's practice a few of these real quick. The first one let's look at is, let's take lead 2 nitrate. Okay, so lead 2 nitrate. Now I'm not going to write the states of matter because we're really just wanting to balance right now. Plus potassium iodide, and both of these are aqueous, by the way, if you wanted to know, and it produces lead 2 iodide plus potassium nitrate. Okay, so I'm going to go about balancing this. The first thing was start with the metals. Now, so lead is 1 here, 1 here, so that's good. The next metal is potassium, 1 on this side, 1 on this side, so that's good. So then I go to the non-metals, and I notice here that I have a nitrate, which is a polyatomic, and a nitrate, and they stay together. So I can count them as nitrates. So on this side I've got 2 nitrates, on this side I have 1. So I'm going to put a coefficient of a 2, and now I have 2 nitrates, but I also have 2 potassiums. So immediately I go to the other side, and I notice I only have 1 potassium, so I put a 2. I've got 2 potassiums now, but I have 2 iodides. So now I go back to this side, and I notice I have 2 iodides. So that should be balanced. 1, 1, 2, then 2 times that is 2, then 2, 2, 2 iodides, 2 iodides. It's balanced. So it's just a kind of a back and forth until you get it done. Let me do another one. So let's do another example. I'm going to go to a different piece of paper. And in this case, let's look at calcium phosphate, now I know this is written correctly because remember calcium's a 2+, which means I'd put the 2 there, and phosphate's a 3-, so I put the 3 there. Plus sodium chloride, a 1-to-1 ratio, 1 plus 1 minus, will react to produce calcium chloride. Calcium's a 2+, chloride's a 1-, so that'd be 1, and then the 2 would go down here. That's written correctly. And then sodium phosphate, Na3PO4. Again, this was a 3-, that means I need 3 here, and this is a 1+, so I need 1 there. So everything is written correctly. Now I'm going to show you, there's a way that some teachers will show you how to do this, and they'll say, okay, what you should do is write each of these down the center. So I've got calcium, I've got phosphate, and I've got sodium. And the reason I can keep the phosphate together like this is because they're together on both sides of the reaction. And then chlorine. Now, I don't like doing this necessarily. I'm just showing you just in case you don't like going back and forth. But by doing this, you'd say, okay, I got 3 calciums on this side. I have 2 phosphates on this side, 1 sodium, 1 chlorine. On this side, I have 1 calcium, 1 phosphate, 3 sodiums, and 2 chlorines. So I would go about doing this. I'd say, okay, if I have 3 calciums on this side and I only have 1 on this side, I'm going to put a 3 in front. As soon as I did that, that goes to 3, and now I have 3 times 2, that's 6 chlorines, so that goes to 6 chlorines. Now, next one down the list is the phosphate. I have 2 on this side and 1 on this side, so I know to get 2 on this side, I need to put a 2 here. Now when I did that, I have 6 sodiums, 2 times 3 is 6, and I have 2 times 1 phosphate, so that goes to 2. So now this is balanced and this is balanced. My sodium is not balanced. So if I have 6 on the product side, I need 6 on the reactant side, so I put a 6 here, which makes this 6, and then the chlorine is 6. And so now it's 3, 3, 2, 2, 6, 6, 6, 6. It's balanced. Now you can do it this way, but remember during a test you don't have much time to do this. So if you can get used to going back and forth, you'll be in better shape. And so I'm going to just practice back and forth from now on. I'm going to do 2 more examples. And so let's look at an example here where we have aluminum plus copper 2 sulfate. And the reason I say that is because there's a copper, sulfate is a 2 minus, copper is a 2 plus, so it's a 1-to-1 ratio. This reacts to produce copper plus aluminum sulfate. Now aluminum is a 3 plus and sulfate's a 2 minus, so I need 2 of these and I need 3 of these. Remember, 3 plus goes down here and the 2 minus goes there. So now I need to balance it. So again, like I said, I'm going to check my metals. I've got this one's by itself, and remember that one rule states that if it's by itself, don't do it right away. So start with metals followed by nonmetals unless the metals are alone. So these metals are alone. So I'm not going to worry about them first. I'm going to look at my polyatomic. Okay, so I have 1 sulfate here, 3 here. So that means on this side I need to put a 3. As soon as I did that, I have 3 coppers. So I go back to the other side and put a 3. Now I just want to make sure everything matches, and I notice I've got 2 aluminums here, 1 here, so I have to put a 2. So that's 2, 2, 3 coppers, 3 coppers, 3 sulfates, 3 sulfates. Now it's balanced. And all I did was go back and forth. Now I'm going to show you one that is a little different, and need to be aware of this because this will happen. If we have calcium hydroxide that will react with HCl, will produce calcium chloride plus water. Now make sure everything's written correctly. That's a 2 plus, 1 minus, so that means I need 2 hydroxides, 1 calcium. This is a 1 plus, 1 minus, so it's a 1-to-1 ratio. This is a 2 plus and this is a 1 minus, so the 2 goes down over here and the 1 goes there, and then this is water. Now I notice here that I have a hydroxide, but I don't see a hydroxide over here. But I do have a hidden hydroxide. If I rewrite water as HOH, I now have a hydroxide. So I have a hydroxide on this side and a hydroxide on this side. So I'm going to start with my metal, calcium 1 and 1, so I don't need to worry about that. I don't have any more metals, so let's go ahead and use the hydroxide. I have 2 hydroxides on this side, I only have 1 on this side. So I put a 2 in front. As soon as I did that, I changed the hydrogen, so now I have 2 hydrogens. So now I go to the other side, I only have 1, so I put a 2. And I look, and there's 2 chlorines, and I check the other side, I have 2 chlorines. So now it's balanced. And all I did was go back and forth. Now the thing is, what you need to do is that if you notice that you have a hydroxide on one side and water on the other, rewrite the water so that it looks like a hydroxide, so it makes it a lot easier to balance. Now the other thing that we needed to look at was a combustion reaction. And remember, combustion reactions, a hydrocarbon combustion, has a different order. We don't go back and forth. It's not back and forth with a combustion reaction. So hydrocarbon combustion reaction. And the order, remember, was you do carbon first, followed by a hydrogen, then oxygen. So if I have C3H8, which is propane, plus oxygen, it will produce carbon dioxide plus water. Okay, so remember it's carbon first, so I have 3 carbons on this side, so I go to the other side, I have 3 carbons. Now, I don't go back and forth now. I go over here and I say I've got hydrogen, I've got 8, here I've got 2, so I need to put a 4. Now I'm going to count water, or oxygen. I'm going to use a different color. So on this side I have 3 times 2, that's 6 oxygens here, plus 4 times 1 is 4 oxygens here. So on this side I have 10 oxygens. Oops, 10. Now 10 divided by 2 is 5, so I need to put a 5 right here. And now it's all balanced. 3 carbons. 8 hydrogens, 4 times 2 is 8. That's 5 times 2 is 10 oxygens. I got 3 times 2 is 6, plus 4, that's 10 oxygens. Now I just wanted to give you an example here of a different one that you'll have to be aware of. Let's say I have C4H10 plus, so that's butane plus oxygen will produce carbon dioxide and water, H2O. Now if I look at this, I notice that I'm going to start with carbon first. So I've got 4 carbons. On this side I've got 1, so I put a 4. Go to hydrogen. I've got 10 hydrogens. I've got 2, so I put a 5. Now I'm going to count my oxygens. So that's 4 times 2, that's 8 oxygens. Let me use green so we can keep. So we have 8 oxygens plus 5 times 1 is 5. That's 13. Now the problem is 13 is an odd number. This is an even number, so I can't divide an even number into an odd number. So I have to make this even somehow. And the way to do that is to double everything except for the O2. So I go 2, 8, 10. Now I'm going to count my oxygens again. So 8 times 2 is 16. So now I have 16 oxygens. And then 10 times 1, so that's 10. So now I have 26 oxygens. 26 divided by 2 is 13. So I put a 13. So this is 2, 13, 8, and 10. And that's a balanced reaction. And we will stop here on writing chemical equations and balancing chemical equations.